And we've been able to talk about rollups, DeFi, different scalability solutions. And now we're going to be talking about like another same but different kind of topic. So we would have the next speaker, Chicho, founder of ETH Storage and QuackChain, to share with us about building the supercomputer. As a OG builder in the space, and obviously with the recent rebranding of QuackChain as one of the prominent L2, hopefully you will be able to shed some light on what is the ambitious project about supercomputers about. Thank you.
Yeah, thanks. Do the clicker? So yes, really glad to share our thoughts on what's the future of Web3, especially with the Ethereum scalability roadmap. So my name is Chijo. I'm the founder of ETH Storage and QuackChain. I have been working in this space since 2018, and then I'm primarily focused on Ethereum infrastructure and also layer 2s and data availability technologies. So today I'm going to talk about our work, especially have been recent 3 years on working on what's the super world computer. Okay, so this is the. So as we all know, like Ethereum is moving towards its scalability roadmap using Rollup approach. The basic idea is to off-chain computation and on-chain verification. So with introduction of data availability technologies, the cost of publishing layer 2 data is significantly reduced. And so right now, the transaction cost of layer 2 is about sub-cents, 0.1 cents. So question is like whether those roadmap is sufficient for the future of Web3 applications, especially we would like to serve billions of users that exist in the current Web2 world. Unfortunately, we also found a couple of issues or missing pieces on Web2, even with the Ethereum current rollout approach. The first is that the onboarding costs of the existing Web2 users is still pretty high. Especially, they still need to create a wallet and also acquire corresponding gas token to initiate their first layer 2 transactions. Second is that the performance limit of Ethereum is pretty limited because of the sequential execution model, which is only about to execute about thousands of transactions, where on a centralized system, we can easily achieve tens or even millions of transactions per second. And also regarding the storage space, suppose we would like to be able to run a fully decentralized tweets, is still impossible. Tweets is able to create about 12 terabytes of data per day, but right now, because of the storage model of the layer 2 nodes, we are only able to serve like terabytes of data. That is pretty limited. And also, the fourth is that we still rely on a lot of centralized components in our Web3 world. For example, we still need to use a centralized server to run our front end, and which can be easily attacked. And lastly, the current validation cost on layer 1 is still pretty high. So let me go through the details. So for the high onboarding costs, there are main two barriers for Web2 users. First, we need to create wallets, and to memorize those private keys for the users will be extremely difficult. And second, even the users is able to create wallets safely, and it still need to acquire the gas token in order to issue the first transaction. One common idea to address this problem is airdrop, which we have seen a lot of airdrops this year. However, they still fail to onboard these users, mainly because they face the incentive misalignment problem. The project side, they would like to retain the users in the ecosystem, while the users, especially those airdrop users, they would like to maximize their rewards. And once the reward has been received, then they just move to next ecosystem. So the DAUs of these projects just reduced from millions to a couple of thousands after airdrop. And regarding the storage side, we know that all the Ethereum nodes, actually Web3 nodes, is using fully replicated fully replicated model, which means that in order to be able to achieve kind of like decentralization level, we would like to, everybody is able to run a layer 2 nodes. And this means that this layer 2 nodes is only able to be able to store a couple of terabytes of data. However, this is almost negligible compared to centralized systems like Tweets, which generates about 12 terabytes of data per day. In terms of the performance, right now the Ethereum EVM is using its sequential execution model. So on the right-hand side, this is the console that's printed by the Go Ethereum, which it will tell how long it takes to process the transaction and what is the number of the gas it can process per second, which is about 100 million gas per second, which is about 4,000 ETH transfers or 1,000 Uniswap V2 swap per second, which compared to centralized system is still far from their performance, which can easily support tens of thousands or even millions of transactions per second. And regarding the centralized front end, most applications, even Ethereum site itself, is still using centralized DNS and the server, which can easily be attacked by, for example, censorship and also DNS and also IP hijacking. So here I just name a few of attacks that we can find every year, and this happens again and again. And so we need new comprehensive solutions to address all this. And one solution is APFS, which addresses the verification issue thanks to content hash. For example, Vitali right now published his blog about APFS and completely give up its Web2 domain, vitali.ca. And unfortunately, APFS cannot offer the same availability as Layer 1 and Layer 2. So in a lot of cases, a lot of data that is stored in APFS just disappear automatically after a couple of years. For example, the early images of the NFT projects. And lastly, the validation cost of Layer 1 in order to prove the off-chain execution is still pretty expensive. So for the validated proof, the prover is super expensive. It in general require dedicated machines, for example, with a large number of GPU arrays. And one way to optimize the prover is to using the ZK EVM approach with customized servers. Unfortunately, ZK EVM is this called ZK EVM scary. The reason is that the Ethereum upgrades on Layer 1, we call EIP improvement proposals, actually I have a couple of them, is unfriendly to the ZK EVM approach, which means the Layer 2s has to re-implement new circuits, audit the code, and test it. And so another approach is for fraud proof, which right now is popularized by OPStack and also Arbitrum. However, it requires a very long withdrawal window, mainly because they require, right now, for example, 73 defend and challenge transactions that is on OP Ethereum mainnet. So in order to address this problem, after observing a couple of these issues, we introduced our Superworld Computer project. It aims to solve all these problems built on top of a highly customized Layer 2 on OPStack, with the goal to serve billions of Web3 users. So here's an overview of our solutions. For the onboarding courses, we will adopt EIP 7702 and SoGas Token. And for performance limit, we are using the parallel execution and IOs. And for the storage space, we are working with Ether Storage, where Ether Storage as Layer 3, so that we are able to achieve 1,000x storage improvement. And then for the centralized front end, we have authored the EIP 4804, which is already finalized in Ethereum repo. It creates a new Web3 standard so that we are able to access the Web3 content and to avoid all those censorship attacks. And lastly, we propose the advanced fraud proof so that we are able to solve this high L1 validation problem and with almost instant settlement. So first of all, EIP 7702 is a very hot topic these days. And if you have, for example, come from DevCon, there are a couple of talks. So the basic idea is able to support account abstraction and is going to be able to support it in the upcoming practical upgrades. So we are one of the team that contribute this idea early. So for example, one idea is to be able to sponsor a transaction using the ERC20 token like USDT. So that now we can easily send a transaction even without gas fee. And also, there's also a couple of features, for example, supporting passkey to create your account easily. And another idea that we are created by us is called SoGas Token. It was inspired by Vitalik's non-transferable token. It is an ERC token that backed by the native gas token. However, the token is not able to transfer any value is. The feature is only be able to pay the gas for the users. It's just like in a Web2 system, it's just like credits points that we can use to pay our services without, for example, without actual the money. And with this SoGas token, we are able to enable super large scale airdrops without selling pressure because nobody can sell it, transfer it. For example, Testnet right now has about 1.3 million airdrop in order to encourage ecosystem. However, after the airdrop is done, then very few users stay. Using our SoGas token, we can easily support hundreds of millions of users or even billions of users, so that we are able to almost enable all the Web3 users to easily onboard and be able to send their first layer 2 transaction. For execution side, we are working on parallel execution and IOs. The main reason for this is that we observe the significant cost of the EVM execution because of loading the data from storage, which takes about 70%. However, the common commodity piece SSD can easily support 10 or even 30 parallel IOs so that we can easily achieve even 10 times performance improvement, which means that we can easily support 10,000 transactions per second with per IO optimization. We have proposed a standard EIP 7650 to enable this feature. And then we are also introducing new OP code so that we can support really large amount of data in random positions in a parallel way. For storage side, we are working on ISO storage, which is a modular Ethereum blob storage layer. It's able to, the idea is very similar to layer 2 with off-chain storage and on-chain storage verification. Also thanks to the support from ESB grant, we are able to offer about 1,000 times improvement, that is about petabytes of capacity using this storage approach. You can imagine this is kind of BitTorrent by using Ethereum, also gas token, as a recurrent payment for the node that is able to run and prove its local data. And with all this data and also large amount of transaction that is enabled on the layer superworld computer layer 2, another problem we want to solve is how we are able to access those rich data without worrying about centralized attacks. And that's why we are proposing this Webstre access protocol. It basically turns EVM into an unstoppable HTTP server. It can support HTTP header, request header response, so that it's more like HTTP server, by just using Webstre as the scheme prefix. And it's defined in ERC 4804, it's finalized, and there's an improvement proposal that is 6860. And we also published the Vitalik blog on top of the Webstre access protocol, and also invite Vitalik as our early users. And lastly, we are proposing an advanced fraud-proof algorithm by using the EIP 4844 blog that was introduced in March. And the basic idea is to publish multiple intermediate execution result on chain so that you can speed up corresponding challenges. Like, for example, I can use ZK fraud proof to prove any small session rather than whole state transition. So with this, we are able to improve the ZK fraud proof to 4,000x bandwidth, or using, for example, like a fraud proof, then we are able to reduce the cost to 10% with about less than 10 on-chain in the transactions, so that we can achieve almost instant finality time. And this work is also supported by 2 OP grants. So here is the outline, and then what is the current progress? Now we have a DAppNet that is ready. It's built on top of OP Stack. Here I list a couple of the contributions. A lot of them have already been merged to the OP Stack upstream. And so we plan to launch a testnet, just finish the DevCon, and once everything is ready, we are able to launch the mainnet in the next quarter. And we also have launched Isosaurus Sepoya testnet. So right now it has very efficient verification cost with about 500,000 gas costs, and finished the first audit. We are arranging the next audit in shortly. And with all this, we are able to build a lot of new applications. One popular topic is the AI, fully on-chain AI on top of the Web3. So we upload the full Llama model on top of the testnet and be able to interference the corresponding model and be able to fully check the corresponding inputs, promotes, matches corresponding outputs. And there's a couple of interesting applications, for example, fully on-chain WordPress and fully on-chain Git. So that now, in the future, we are able to develop a Git, develop Ethereum on top of Ethereum. Unlike for external cache, it is censored by US, so that nobody is able to develop on top of that. It's archived by GitHub. And there's also a couple of other fully on-chain applications, social networks or like gaming. Anything is possible. So this is pretty much all I have today. If you have any question or interest in our project, feel free to reach out to me to my tweets. Also, I'm happy to answer any questions after stage. Thank you very much.